Last example, another rational expression. I chose this one specifically. It's not going to have the same format because it wasn't out of my teacher book. I had to kind of look online to see if I could find an example. I had another one that was probably better, more complicated, but I chose the easier one. I'm sure your homework is going to work you out intensively. So, so take that for what you will. So let's take a look at this. I can tell that this is a rational expression. Rational expressions usually have some kind of this behavior. So I'm expecting to see something like that. As far as the domain, I know that x is not allowed to be positive 1, excuse me. And I do know that I have a x-intercept, or where y is equal to 0 at x equals negative 5/2. So I have some kind of an x-intercept there. I have a y-intercept. In this case, I have a y-intercept at what, negative 5, right? 2 times 0 would be 0, so plus 5 would be 5 over 0 minus 1, which is negative 1. 5 over negative 1 would be negative 5. This is definitely an asymptote, so the limit as x approaches 1 from the right, and I don't have anything problematic in terms of there. There's no L'Hopital that I can use. I just end up with something undefined. So as I go from the right, that's going to be positive in the top, but it's going to be positive on the bottom. So that asymptote would go to positive infinity without bound. And then the limit as x approaches it from the right, now we're talking about things that are less than 1, and that's going to make that denominator negative, while that's going to remain positive. So that's going to turn out to be negative infinity. And then last but not least, we've got the limit as x approaches infinity of y. Now, this is where it gets tricky because that's infinity over infinity. So we have that L'Hopital, so that we can call it the limit as x approaches infinity of 2 over 1, if we use L'Hopital, which is going to be 2. And that's going to be the case if it's positive infinity or negative infinity, which means we have a horizontal asymptote at y equals 2. So we have got an asymptote at x equals 1, a vertical asymptote. We've got a horizontal asymptote at y equals 2. So that's what makes this graph a little bit different. So I'm going to create the table next, and the first and second derivatives with the CPs and the POIs and the asymptotes. So I'm not going to fill in the table, just the structure. Okay, so this is my graph. I started to show you one thing and I realized I forgot all the algebra. So let's do the algebra calculus stuff. All right, here is the original equation. Quotient rule. Did some simplification for the numerator. Got that as my final. It means there's no CP because there's no place that could be 0. But I still have this asymptote. And then I did some trickery. I was like, oh, I don't want to do quotient rule with that. Pop that x minus 1 to the second power in the numerator with a negative 2. Made a really easy second derivative. And I had no POI. So all I've got happening is this asymptote. So this is a really simple table. So simple, I'm not even going to bother filling it in on the separate thing. I can do this when I did it. Pause here if you want to think about it on your own. When I did it, I ended up with a negative and a negative, a positive and a positive. Nope, I lied. A negative and a positive. So then that means decreasing concave down. Decreasing concave down. Decreasing concave up. Now remember, at this asymptote, we discovered that it was down to infinity and up to infinity on either side of the asymptote. So this goes in line with what we've got happening here. This is a up to infinity. This is a down to infinity. Okay? Now, remember, this is now an asymptote of the other side. So when we draw this graph, and I'm actually not going to draw it because I pulled off the internet, I didn't have a nice pretty piece of graph paper. I'm going to show you in a second. When I draw this graph, I think I'll put it over to the right side. You can see that's what's happening. Okay, so now I've included the graph off to the right. You can see I fully stole it off the internet. So right here is that asymptote at negative at 1, that vertical asymptote. And sure enough, on the right side it's up to infinity, on the left side it's down to infinity. And then here is that horizontal asymptote too. And sure enough, notice that it plunges down, but never touches it. There's that asymptote as it goes to infinity. Plunges up, but never touches it as it goes to negative infinity. And so that's the way you would consider the horizontal asymptote. Okay, so now we are ready for the last step, which is some homework. Now, I don't have, unfortunately, I don't have the my assignment that I would have given you. That's sitting in my classroom, and I can't go back. I actually had to pull up. I was able to find my teacher materials, which is where I generally pull my questions from that I lecture from the book, and recreate them at home and to where I could give them to you. However, I couldn't pull up the home fun questions that I sent, and I don't have my textbook, so I can't show you that either. So I'm going to go with what they suggest, which could be scary. I apologize if it is, but I'm going to assign it anyway, and then I'll deal with the aftermath when we come back. It can't be bad practice. Maybe it would just accentuate some harder problems of what I might assign on a test, and it might include some of these limit things that we already covered last time. So let's do, this is 4.5. And they've suggested 1, 10, which I know you don't have the answer to, so do what you can with it, 13, 17, 21, 37, 41, 47, 51, 57, and 63. That's what they've suggested. So feel free to start practicing that. And then when I get back to school, I can, on the odd day, because I'll be back on an odd day, I can round it out with any additional questions. Or if I see one that just from the get-go I can tell is not important. But I can't imagine any of these would be bad practice. It's just a matter of this is what the textbook makers suggested rather than what I've kind of honed in after teaching this for a couple years. So take it for what you will. And I hope you have a fabulous holiday break. Good luck, and I will see you next year.